Alright guys, welcome back. This is still Unit 3 and we are now on video 3 of Unit 3. So here we go, atomic components and isotopes. Alright, so here's some components of the atom, and most of you have heard of these through your years of science. You've at least heard the words, so make sure that you understand what these are. So protons, positively charged portion of the nucleus. Often you'll see it written as a P with a plus around it, just like right here, right? Next one, neutrons, portion of the nucleus that contains no charge, but contains the same mass as a proton. Okay, a lot of times you'll see it written with an N. And sometimes you might even see it with N and a little zero for no charge. Some people have seen write it like that. All right. Then you've got electrons. They are a very light, negatively charged particle found somewhere outside of the nucleus, okay? But we're not exactly 100% sure where they're always at, all right? It only weighs 1,837th of a proton, okay? But its negative charge is as powerful as the positive charge of a proton. So it is way, 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 way smaller than your protons and neutrons, okay? So it's so small that it's not even used in calculating the mass, okay? But your protons and your neutrons are, these two guys here, relatively the same size, all right? So moving on. Atoms, oh, we missed the fill in blank here. Atoms are always neutral, meaning what? Meaning that they have the same number of protons. Sorry about that. And I'm just going to write the abbreviations, okay? Protons and electrons, all right? Atomic number, the number of protons found in the nucleus of an atom. Atomic number defines one element from another. It's the large whole number in the upper corner of the periodic table. And some periodic tables are a little different, but just look for the whole number. And that's going to tell you your number of protons. So just remember, very important here, this is your number of protons, all right? And that is, most importantly, what defines an element from another, okay? So that's how we determine an element. Next is your mass number, which is the number of protons plus the neutrons found in the nucleus of an atom, used to identify isotopes. So let's go ahead and write out mass number equals your protons plus your neutrons, okay? So anytime you got to find one or the other, all you have to do is either add the protons and neutrons together, or if you have a mass number and you know the number of protons, then you should be able to find neutrons by subtracting, okay? And then your last one down there is your atomic mass, all right, which is an average of all the masses of the isotopes, which we'll talk about a little bit more in depth here in just a minute. And they're weighted by how abundant they are, all right? All right, so those are some of your keywords you need to know about the atom. All right, so we're going to go ahead and jump into what the isotopes mean, how they work, how we figure them out, all that stuff. All right, so what are isotopes and how are they different? All right, so changes in the number of neutrons and hence the mass number. All right, this is how we know something is an isotope. It will have a different number of neutrons and a different mass number than we are normally used to. So if you look on a periodic table, we will see just our regular old carbon-12, okay? Make sure you remember that this number here is your mass number, okay? You write it with a hyphen notation using the name of the element, which in this case is carbon, and then using the mass number, hyphen, and then the mass number next to it. That is what we call the hyphen notation for isotopes, okay? So carbon-12, 12 is your mass number. Then we know the number of protons, okay? Because remember, protons identify an element. We can go to carbon, and the number of protons, which is 6, will never, ever change. If you look right here, 6 protons. Doesn't matter which isotope we have, you just need to remember you can always identify an element from its protons, okay? The protons of the element do not change. If the protons change, that means you have a completely new element, all right? So on the previous slide, we talked about how you find the number of neutrons, and you just use your formula, which is mass number equals, so I'll go ahead and do over here again, mass number equals protons plus your neutrons, okay? So we have a mass number of 12, And we have a proton number, of 6. So all you have to do is subtract your protons from your mass number, and that will give you your neutrons. That's how we get 6 neutrons. Okay? If you see carbon 13, okay, it's carbon, but it's another isotope of carbon. So we notice we have our name and our hyphen mass number here. So that's the new mass number we're dealing with. So again, to find the neutrons, all you do is you take your mass number minus your protons, which once again never change. All right, so minus 6 protons, and this time it's going to give us 7 neutrons. Do you see how the neutrons are changing? That is what we call the isotopes. Okay, same thing over here, 14 minus protons of an element, never change. We are left with 8 neutrons. So our neutrons have changed from 6 to 7 to 8. Okay, that is what we call an isotope. All right. Okay, so moving on, here are some practice problems for you. And if you can go ahead and pause it here, and then we will get back with the answers in just a moment. Okay, so what's the difference between mass number and atomic mass? Okay, remember your mass number is just your number of your protons plus your neutrons, okay, in an atom. And then your atomic mass is an average of all those different isotopes, like the carbon example for your isotopes that we did. Okay, the average of your isotopes. How's the mass number calculated? Well, we just wrote that, protons plus neutrons. Where can the atomic mass be found? Okay, this is going to be found on your periodic table. And because it's the atomic mass, it's usually going to be the decimal number. Okay, how many protons are in sodium, and how do you know? Okay, well, we know in sodium, here we go, which is Na, we just have to find it on the periodic table. Okay, so when you find it on the periodic table, the atomic number or proton number of sodium is always going to be the same. Okay, it's always 11 protons. Okay, how do we know? Well, that's what it tells us from the periodic table. Okay, how many electrons does calcium atom have, and how do you know? All right, calcium atom has 20 electrons. Well, how did I figure that? Well, I went to the periodic table, I found calcium, and I noticed that it had 20 protons. Well, in a neutral atom, we can always assume protons equals electrons. Therefore, I have 20 electrons. What happens if the atomic number changes? Well, then we have a new element. The element changes. There's a new one. All right. All right. How many neutrons are in uranium-235? How did we get that? Well, we took 235 minus the number of protons, gives me my number of neutrons. Okay. Identity of an element with 3 protons, 4 neutrons, and 3 electrons is going to be lithium. How did I figure that out? Well, a proton number will identify any element you're looking for. Write the hyphen notation for element in number 8. So element number 8 is oxygen, okay? And we use the mass number, so we're going to round that number on the periodic table to 16. That is our mass number. Make sure you don't use the 8 because that is the proton number. Okay? Another way to remember is that protons are always less than the other number that's on the periodic table, so the smaller number on the periodic table is your atomic number. Okay guys, so that is the end of this video. Don't forget, if you need to come into tutoring, here's our schedule, our room numbers, and where you can find us. Have a great day.